This video is going to cover the Geometry Spring Practice Final. This was a 67 question multiple choice practice for your upcoming final. So we start with number 1. It says if the length of one leg of a right triangle is 4 and the length of hypotenuse is 12, what is the length of the other leg? So if we draw this, we can get a clear picture of what we're really looking for here. We have 12, 4, we need the other side. Well, this is going to be a Pythagorean theorem problem. 12 squared equals 4 squared plus x squared. Get 144 equals 16 plus x squared. 144 minus 16 is 128. So now we have to take the radical, to take the square root of 128. If we look at the square root of 128, that's really 2 times 64, which is, 64 is of course 8 times 8. I can take that out, and I'm going to say it's 8 root 2. In number 2, same again, Pythagorean theorem, but this time they give us the diagram. It's going to be 8 squared equals 3 squared plus x squared. 64 equals 9 plus x squared. We then get 55 equals x squared, which becomes x equals the square root of 55. Can't simplify that anymore because 55 is just 11 times 5. They're both prime. It doesn't factor down, so we're just going to go with B. Number 3, and 4 for that matter, are both using Pythagorean theorem as well, but now it's looking at the converse. So now we're going to test to see what type of triangle this makes. So 34 squared equals 16 squared plus 30 squared. 16 squared is 256. 30 squared is 900. That gives me 1156 on the right side. Now, if 34 squared is in fact 1156, then I have it's a right triangle. If it's less than, it's acute. If it's greater than, it's obtuse. Well, it does turn out to be 1156, so it's going to be a right triangle. In the fourth one, we're looking at which one forms a right triangle. So it's using the idea we did up in number 3, but now it's seen with these values. So we can kind of quickly check, because we want them when we set it up by Pythagorean theorem, of course longest side by itself. If it comes out equal, it's good. If it's not equal, it doesn't necessarily matter what the values are as long as it's equal or not. That's what we're looking for. So I get 81 equals 64 plus 36. That's 9 squared equals 8 squared plus 6 squared. Well, that's not going to work. Not equal. That one's out. For B, I get 36 equals 16 plus, well, I need 2 root 3 squared. If I square that, I square the 2, I square the radical, leaves me with 12. So it's 4 times 3 or 12. We look, that's not going to be equal. That one's out. C, I get 3 root 2 squared. Let's do that over here. That's going to be 9 times 2, so 18 equals 9 plus 9. That comes out to be equal, so C is in fact our answer. Just to make sure, let's check the last one. We get 25 equals 16 plus 4. Yep, not equal. C is the one to go with. 5 and 6 are looking at the geometric mean, and we can do this by just drawing similar triangles. So I have this triangle here with the x and the 5, and I can draw that over here. And then if I take this triangle and rotate it so it faces the same direction, almost turn it 90 degrees clockwise, I get x and 3, as so. Now, they are similar triangles in this case, so I could say x over 3 equals 5 over x, gives me x squared equals 15, and x is the square root of 15, so my answer is D. For number 6, we're going to do the same thing. I have that triangle on the left. It looks like this. I'm going to take this triangle and rotate it, this time 90 degrees counterclockwise. So it's now x and 6. Now I can set up a proportion. 6 over x equals 8. Oops. Be 6 over x equals 8 over 6. That's 6 squared equals 8x. 36 equals 8x. 36 over 8 equals x. We can simplify that down. We can divide them both by 4. And that gives us ultimately 9 over 2. Our answer is B. In number 7 and 8 for that matter, we're looking at special right triangles. 7 is looking at a 45, 45, 90. If they don't give you the angle measures, but they tell you they're the same, we're going to say that they're both 45. So I'm going from the hypotenuse to the shorter leg, or just hypotenuse to the leg in general. Both x and y will be the same. So maybe that's something you can look at in your answers. I know in a 45, 45, 90 that x and y are the same because they're the legs. So that means these are pretty much out because they're not the same. So it's either going to be 10 or root 5. So I'm going from hypotenuse to leg. I'm going smaller. So I know it involves root 2. I'm going to divide by root 2 because I want to make it smaller. So it's the square root of 10 over the square root of 2. I'm going to simplify that. I get the square root of 20 over 2. The square root of 20, well, that's 4 times 5. So that would be 2 root 5 over 2. We get root 5. B is our answer. We could even put 10 there and tested it. If we take 10 and we multiply it by root 2, doing the opposite, that wouldn't work. So we could see there it is going to be root 5. Number 8 looks at a 30, 60, 90. And we start with 6 root 3 being the longer leg. To go to the shorter leg, I know that the relationship between the longer leg and the shorter leg involves root 3. I'm going to divide by root 3. So x becomes 6. 6 root 3 divided by 3 is just 6. Now I'm going to go from shorter leg to hypotenuse. That involves 2, so I'm going to double it. It's going to be 12. So I want the answer where x is 6, y is 12. That is C. Number 9. Now we're looking at cosine. So we need cosine of b, which is here. Cosine, we should know, is adjacent over hypotenuse. Now if we're looking at b, 8 is adjacent to it. 17 is the hypotenuse. So cosine of b should be 8 over 17. Number 10, which equation can we use to find x? So now it's picking sine, cosine, or tangent. If I look at this one, I have the x is adjacent. The 50 is the hypotenuse. So if I'm going to use the 20, I'm going to use cosine and say cosine of 20 equals x over 50. If we look, if it's there, looks like we have it, we can go with D. Now, realize if that didn't work, if that answer was not there, we would have to go to this angle over here, and we could have said sine of 70 equals x over 50. You have to be aware of that. It could ask you for the other angle, and you'd have to find that, and you could do that. It's not a problem. Okay, 11, which equation, just like the one we did, are we going to use for angle A? So if we're looking at A here, this is the opposite, this is the hypotenuse. So opposite and hypotenuse is sine. So I'm going to say sine of A equals 7 over 12. We're going to go with answer A. Number 12, which equation could be used to determine the value of y? So for y, I could try sine of y is opposite over hypotenuse, 8 over 10. Cosine of y is adjacent over hypotenuse, 6 over 10. Tangent of y is opposite over adjacent, 8 over 6. I have my answers now. Just look for which one matches. Looks like D is my best one. Sine of y is flipped. Cosine of y is actually sine, so that's out, that's out. And then the tangent of y is flipped, so D is our best answer. Now we're shifting to the next chapter. So we're looking for the value of x in the quadrilateral shown. We're looking at interior angles. Our rule for interior angles, it's the number of sides, or number of angles, which is 5, minus 2 times 180 is going to give us the total. So 3 times 180 gives us 540 degrees. So I know all of those angles have to add up to a 540. So I'm going to take what I know, subtract it from 540, and find what's left. So we write it out as 540 equals 103 plus 89 plus 122 plus 87 plus x. So I can add these all up. 103 plus 89 plus 122 plus 87 gives me 401. So 540 equals 401 plus x. I could subtract that now from 540, and I get 139. Now realize on these, and really a lot of these problems, it doesn't necessarily mean they're to scale. It warns you at the beginning of this assignment, so don't sit there and say, oh, well, that angle looks like it's going to be obtuse, so C and D must be the options. Yeah, it did turn out to be C, but it's not to scale. That's not guaranteed. Do the math, do the work, stick to the rules we have, and don't just look at the picture and try to find the best fit. Just some advice there. Okay, determine the measure of the sum of the interior angles. So we want the total of the interior. We're going to use this idea we did up here. So that's going to be 13 minus 2 times 180, 11 times 180. We multiply that, it comes out to be 1,980. It's not asking for each. If it asked for each in a regular 13-gon, we would then divide that by 13, but didn't ask for that. A is our answer. Also, if it asked for exterior, the total would have been 360. But it was interior. So 15, determine the measure of one interior angle when it's a regular hexagon. So I'm going to find the total for a hexagon, then I'm going to divide that by 6. So 6 minus 2 times 180 is going to give me my total. That comes out to be 720. Now I'm going to do 720 divided by 6 and get 120 degrees. That is my total for each interior angle of a regular hexagon. 16, determine the measure of the sum of the exterior angles. So, sum of the exterior, the total of the exterior. It doesn't even matter how many sides it has here, because we know for exterior it is always 360. 17, determine the measure of one exterior angle of a regular hexagon. So we want 1 in a hexagon. Well, 360 is the total. In a hexagon there's 6 sides, also means there's 6 angles. 360 divided by 6 is 60. So we get answer is C. Now notice on 15 and 17 we had the interior angles of a hexagon, and here we had the exterior of a hexagon. 120 and 60 add up to 180. They are supplementary, and they should be, because the interior and the exterior will be supplementary. So if you ever had, say, one interior and you wanted the measure of one of the exteriors, and it was regular, you could just subtract from 180 to find your answer. Okay, 18, we're looking at a non-regular shape, but we need to find the value of x. It's exterior, so we know that the angles add up to 360. 360 equals 86 plus 70 plus 2x plus x. 360 equals 156 plus 3x. I'm going to subtract 156 from 360, and I get 204 equals 3x. Divide that by 3, and I get x is 68. On to our next page. Number 19, we have our points plotted. We're looking for which would make a parallelogram. Now in this problem, typically the first thing we try to do is I notice, well, okay, I go over 3 points to get to this one. I'm going to go over 3 points to get to this one. Okay, that makes a parallelogram. That's good, and we can even see that the coordinates here would be 3, negative 4. We then go and look at it, and that's not one of our answers. Well, that doesn't mean we pick a point next to it. It doesn't mean 2, negative 4 works, or even 5, negative 4. There's other options. So with using that same idea, using how we got from one point to the other to be our guide, I would go up 3 over 1. Get my hand out of the way. Up 3 over 1 to get to this point, so I could go up 3 over 1 to get to this point. And this would also give us a parallelogram. Now in this case, that would be 5, 2. And that is our answer we're going to go with. It still makes a parallelogram. Now, just to go one step further, maybe that didn't work. We could come back down. We went 3 to the left. We could go 3 to the left and pick that point as well, and that one would also make a parallelogram. So work through there, try to find the other points. Another way you could have tried it is, well, plot these points and see which one made a parallelogram. All right, number 20, we're looking for the value of x when it is a parallelogram. When we do have a parallelogram, the diagonals bisect each other, so 2x plus 4 equals x plus 8. I get x equals 4. 21, we're looking for the value of x. Two ways we can think of this. We know that consecutive angles are supplementary, in a parallelogram, so that means this angle plus this angle adds up to 180. You could also take into account that alternate interior angles are present, so you could put that 37 there. And in that case, it's x plus 37 plus 110 adds up to 180. In either case, we're adding them up, setting them equal to 180. We get 147 plus x equals 180, so x is 33. 22. Solve for angle 1 and angle 2 in our rhombus. Now in a rhombus, we know that diagonals are perpendicular. So I know right off the bat that angle 2 is 90. So it's any of these, so D is out. And then I also have that the angles are bisected. So this is 34, 34, 34. What I ultimately have here, though, is 4 right triangles that are all the same, and they're just kind of reflected in different directions. So really, to find angle 1, it's the other angle in that triangle with the 34 and the 90. So we could ultimately do 90 minus 34. We get 56. That's this angle, this angle, this angle, and this angle. So our answer turns out to be B. 23, we're looking for AB. Now this is a rhombus. I realize it doesn't look like a rhombus because it is stretched out a little bit. It looks a little bit more like a parallelogram, but trust the question, trust the words. They give you what is given. So these are in fact the same. 7x minus 6 equals 3x plus 2. We get 4x equals 8 and x equals 2. When we look, oh look, there's B. The answer is 2. That is not, though, what it's asking for. It's asking for AB. So we need to take that 2, plug it back in to 7x minus 6. We get 14 minus 6, or 8. 24, we have a rectangle, and in a rectangle, this triangle here is actually going to be an isosceles triangle. And that's because the diagonals are congruent. So this triangle becomes isosceles. If that's 28, so is that. And then still in this triangle, I could add these two together. Plus x is equal to 180. We get 56 plus x equals 180. X equals 124. That's B. Okay, 25, measure of angle A in the trapezoid. Now, we have A and B. A and B are in fact supplementary, but we can't really solve with them because we don't know B. So what we're going to have to do is we have to use C and D. The fact C and D are supplementary, we can add those up. Set it equal to 180. I get 4x plus 8 equals 180. 4x equals 172, and x is 43. Now, not our answer. We have to still plug it back into A. So that's 2 times 43 plus 1. That comes out to be 87. So B is our answer. For 26, we're looking for the length of MN. That is a midsegment. That is the average of the bases. So for this one, MN is equal to 8 plus 14 over 2. 22 over 2, or 11, is our answer. 27 works the same way. It's still a midsegment. So 10, the midsegment, is equal to the average of the bases. 2x minus 4 plus x minus 3 divided by 2. We get 10 equals 3x minus 7 over 2. And then I multiply the 2 over, and I get 20 equals 3x minus 7. Let's go up here. 27 equals 3x, so x turns out to be 9. Now, not our answer. We're looking for, in fact, DC. So we get 9 minus 3, or 6. For 28, a segment whose endpoints lie on a circle is defined to be a blank, and it is a portion of a blank. So let's draw it here. If I have endpoints on a circle, what type of line is that? Chord, diameter, chord, or secant? Now, endpoints on the circle means it's inside the circle. It's not going to be a secant. It doesn't say anything about the center. It just says it's on the circle, so it's not going to be a diameter. So it's going to be a chord. Now, that's a portion of a line that goes beyond the circle. So that line outside the circle is either a secant or a diameter. Well, diameter has to go through the center. It's inside the circle. That one's out. We're going to go with A, chord and secant. For 29, we need to see which of these statements are true, and then we're going to take these true statements and see which combination works. So, more than one of these will be true, and we see which one fits. So, let's just start working through them. BP and PE, these two are radiuses. Radiuses are the same. That one checks out. Let's try again. BC and DE. Let's see. BC, DE. Well, that looks like we have a trapezoid. These angles would be the same, so this one works. AB and AF. AB and AF are tangents. That would work. BC, CD, well, this one doesn't look like it's going to work. We have a parallel here. We don't have if the angles are the same. We're pretty much safe to say that one's out. So 1, 2, and 3 will be our answer. Answer C. What you could have also done there if you weren't sure is go through and find ones you could eliminate. We found that 4 definitely didn't work. So that would eliminate any answer that has 4, which, as we can see now, is A, B, and D. It just leaves C left. Okay, number 30. We need to find angle G. Angle G is outside the circle. So the measure of angle G is going to be the big arc minus the little arc divided by 2. Now, I know the big arc is 70. I have to find the little arc. Now, this cuts the circle in half, so that means this top half is 180. 70 and 80 is 150. That leaves 30 here. So it's going to be 70 minus 30 divided by 2 is 20 degrees. For 31, now I have angles inside the circle. So that's angle 2. It's going to be arc plus arc divided by 2. But these arcs have to match up. They have to match up to the vertical angles. That 100 is not one that's going to work. We have to find the one down here. Now, this does cut the circle in half, so this would be 180. That's 100. It leaves 80 there. So I'm going to say 110 plus 80 over 2. 190 over 2 gives me 80. Try 95 degrees. Okay, for 32, we have QS is 20. US is 4, and QS and TR are perpendicular. So we need to find TR. Now in this type of problem, whenever we have perpendicular or right angles, which come with perpendicular, I'm going to look for right triangles, I'm going to look for Pythagorean theorem. And actually I can make a right triangle right here. And let me redraw this triangle we're ultimately going to use. So that's P, U, T. Now, I know 20 is the diameter. That means the radius is 10. So that is also 10. Okay, now this also means from P to S is 10. Well, U to S is 4. That leaves 6 right here. So we can use that to help us find TU. Now how is that going to help us? Well, eventually we're looking for TR. So we find TU. That's the same value on UR. We double it. We have our answer. So let's just call that X for now. 10 squared equals 6 squared plus X squared gives us 100 equals 36 plus X squared. We get 64 equals X squared, so X is 8. TU is 8. That means TR is 16. Okay, 33, we need the length of the arc AB. So length we want to think with circumference. So anytime we have circumference, it's 2 pi r. But if it's not the entire circle, we want the fraction of it, which is going to be the angle or the arc measure over 360 times 2 pi r. So now we fill in what we have. That's 120 over 360 times 2 pi times 12. I can reduce 120 over 360, and that actually becomes 1/3 times 24 pi, and that is 8 pi. 34, we're looking for the value of x in our circle. If we look at x, x is a central angle. The central angle is the same as the arc, so easy enough, it is just 48. 35, we're looking for angle 1. Well, let's see. We have a central angle, so that means this is 40, because it's at the center. If it wasn't at the center, we'd be in trouble here, because we couldn't just automatically assume it's 40. But that's 40, which means the angle next to it, we could just take 180 minus 40, leaves us with 140 degrees. That is answer A. 36, pi is the ratio of the blank of a circle to its blank. This comes back to our definition of pi. It has to do with, we get it from circumference. So circumference we can automatically see is involved. And if we think back, circumference is equal to pi times diameter. That means pi equals c over d. That's the ratio of circumference to diameter. Answer C. 37, we're looking for the measure of angle 1. Now if we get rid of all the extra information and just focus on that angle is on the circle. That means it is inscribed. That means this angle is half of its arc. Well, its arc is 130. We get 65 for our answer. 38, we have AF is 10. AD is 13, CF is 5. Well, if AD is 13, that means FD is 3, and we're looking for EF. So I'm going to say EF times 5 equals 10 times 3. 5 times EF equals 30. EF equals 6. For 39, we're looking for GD. Let's just put an X there and see what we have. GC is 12, GB is 4, GA is 3. This is a problem we're looking at secants. In this problem, it's the secant, the entire segment, times the external, the outside. We can set them equal. So I'm going to say 12 times 4. The entire line times the outside is equal to the entire line times the outside. It becomes 48 equals 3x, and we get x is 16. For number 40, we're looking for arc length. Now we have a radius is 9, so this is going to be angle over 360 times 2 pi r. 130 over 360 times 2 pi times 9. I get 13 over 36 times 18 pi. I can reduce those. That becomes 1 and 2, 13 pi over 2. For 41, now it's area of the shaded region. So we're still going to use the angle over 360, but this time it's pi r squared because it's a fraction of the area. So 30 over 360 times pi times 8 squared. I can reduce 30 over 360 to 1/12 times 64 pi. 64 and 12, I can divide them both by, well, we can divide by 4. If I divide them both by 4, I get 16 pi over 3, and that will be our answer. 42. Now this one's a little bit different approach. We have a radius is 2. The area of the shaded region, so this area is 14 pi over 9. We need to find the angle. So we're going to take that same idea. It's angle over 360 times pi r squared, and that's going to give us the area. But now we have to kind of set up the parts we know. We know now the area is 14 pi over 9 is equal to the angle, our unknown, over 360 times pi times 2 squared. So this becomes 14 pi over 9 equals 4 pi over 360 times x. And I just switched these two, which I can do because it is multiplication. So now I have to simplify here. Now, before I look to simplify, I can kind of look to solve it. I can simplify some things. First of all, I have a pi on both sides. I could divide both sides by pi, so those are gone. 4 and 360, I can reduce those. That's going to become, divide them both by 4. I get 1 and 90. So this is actually 14 over 9 equals x over 90. Now we've broken it down so it's just a proportion problem, and we can just do cross product. This becomes 9x equals 14 times 90. 14 times 90 is 1260. We then divide that by 9, and we get 140 degrees. That's right over here. So our answer is C. Alright, our rhombus has diagonals of 16 and 30. We need to find the perimeter. So, rhombus, the diagonals are bisected, so instead of writing 16 and 30, I'm going to write 8, 8, 15, 15. Now, I know the diagonals are perpendicular, so I have all these right triangles inside. To find the perimeter, I'm going to need one of the sides. All of the sides are the same, so if I knew the perimeter, I could just multiply one of those sides by 4. So I'm going to take this triangle out. And I can set up a Pythagorean theorem problem and say x squared equals 8 squared plus 15 squared. X squared equals 64 plus 225. X squared equals 289. So that means x is 17. So each side is 17. So to find the perimeter, I'm going to do 4 times 17, which is in fact 68. Our answer would be C. Now we're going to calculate the area of our rhombus. Perimeter is 40. Now if we just did that problem, we know if the perimeter is 40, each side is 10. The diagonal is a length of 12 feet, but we don't want that whole thing. Again, we want just half of it, so it's 6 and 6. So now we have to find the area. Well, area of a rhombus is 1/2 diagonal 1 times diagonal 2. We know one of the diagonals is 12. We need to find the other one. We need to find this one. Now, we're going to take the same approach we just did, though, and do a Pythagorean theorem to find it. So I have 10, 6, and we'll just call that x. If you did Pythagorean theorem, 10 squared equals 6 squared plus x squared, it comes out to be 8. So my diagonal is then 16. It's 1/2 12 times 16, and that is 96. For 45, we're looking at the area of an equilateral triangle when side length is 24. So this is using equilateral triangle or regular polygon, so it's 1/2 the apothem times the number of sides times side length. Now, let's get some things out of the way. We know there's 3 sides. We know the side length is 24. So I need to find the apothem. Now, we could take this triangle out here, and it is a 60, 30, 90. Let's draw it over here. And when I do that, I cut that 24 in half because it's just 12. Now, I want to find the shorter leg. In order to find the shorter leg, I'm going to divide by root 3. So 12 divided by root 3, in fact, becomes 4 root 3. That's my apothem. So now I can plug it in to solve. I get 2 root 3 times 72 and 144 root 3. So that is C. Now, the other way you could have done this problem, real quick, let's just make some space. Since it is 24 here, I could have gone and cut this in half. This is 12. This is 24. I could have found this height and then just did 1/2 base times height. In doing that, the height would have been 12 root 3, so it would have been 1/2. We're off here somewhere. I see my mistake. Yeah, so we would have found it. It would have been 12 root 3. So it would be area is 1/2 24 times 12 root 3. A little bit out of space. It does come out to be the same thing. It'd be more common to go with this method. That's using the regular polygon. That's one we're going to see on this next one, on 48, on 49. So that's the easier method. But you always have a shortcut when you go through it. Just be careful. Where I got a little confused was I was trying to look at 12 being my side length, but make sure 24 is still your side length when you do that. All right, on to 46. Perimeter of the equilateral triangle when the radius is 8 root 3. So this one we're going to have to make that special right triangle. So let's just draw it over here. Now the reason why we have a 30, 60, 90 pointed this way, this angle formed here is 360 divided by 3. 360 divided by the number of angles. So that's how I get that 60. I have a 30, 60, 90. You could also think of in an equilateral triangle, all these angles are 60 on the outside. I've cut this one in half, so that's 30. So now it's a 30, 60, 90. It just always works out that way in an equilateral triangle. Okay, so I have my 30, 60, 90. Hypotenuse, I'm going to shorter leg. I take half of it, so that's 4 root 3. And then to go to the longer leg, I multiply by root 3. So it's 4 root 3 times root 3, which we just talked about, becomes 4 times 3, or 12. That's 12. Same on this side. The whole side length would then be 24. And I want the perimeter, so it's 24 times 3, which is 72. Okay, area of a trapezoid. In order to find this, we need to find the height. Now if I'm looking at this triangle, if this is 6 and this is 9, that means we have 3 extra right here. We could do Pythagorean theorem, 5 squared equals 3 squared plus h squared, to find the height. And if you do that, the height comes out to be 4. So my area formula for a trapezoid is 1/2 the height times base 1 plus base 2. 1/2, 4, times 6 plus 9. I get 2 times 15, or 30 is my value. 48, we have a square inscribed in a circle with radius 5. What is the area of the square? You could do this method, but let's take a different approach. Make it easier for ourselves. Now, a square is also a rhombus. If that's 5, so is that. So is that one. So is that one. That means the diagonals are each 10. So instead of using a regular polygon, we're going to use the formula for a rhombus. 1/2 diagonal 1 times diagonal 2 comes out to be 50. I would have done this method. I would have made 45, 45, 90 triangles. My apothem would have been 5 root 2 over 2. Number of sides is 4. Side length is 5 root 2. You plug it in. It does come out to be 50 as well, if you did it that method. All right, determine the area of a regular hexagon with perimeter of 72. So if it's 1/2 apothem times number of sides times side length, we actually already have these two parts because the number of sides times the side length is 72. So it's 1/2 the apothem times 72. We just need the apothem. So let's find that. Now perimeter is 72. So that means 6 sides of 12 units each. I'm then going to take out a right triangle here. And this is actually a 30, 60, 90. Where this is not 12, but 6 right here. And the apothem is 6 root 3. And that's half the side root 3. So I get half of 6 is 3, 3 root 3, times 72 gives me 216 root 3. Only 17 more to go. It's like the 7th inning stretch. Alright, area of a triangle is 56 meters squared. We know the base is 7. We need to find the height. It's very easy just to look at this problem and say, oh, 56 divided by 7 is 8. There's our answer. We move on. But area of a triangle, we have to remember 1/2 base times height. So it's 56 equals 1/2 7 times h, or the height. Now we can solve for the height. Now I'm not going to take half of the 7. Instead I'm going to multiply both sides by 2 to get rid of the 1/2. That gives me 112 equals 7h. I then can divide 112 by 7 and it comes out to be 16. Our answer is A. 51, the circumference of a circle is 24 pi. We need to find the area. Now circumference is 2 pi r, so we're saying 24 pi equals 2 pi r. If I divide 24 pi by 2 pi, I get 12. So my area, which is pi r squared, is pi times 12 squared. 144 pi is my answer. 52, the ratio of the lengths of the corresponding sides, or our scale factor, is 4:9. We need the ratio of the areas. To get that, we're going to square 4/9, and we get 16/81. Answer is D. For 53, we have similar figures, so the scale factor is 3/6, which always reduces to 1/2. We now want to find the area. So here we know the area is 35. We want to find the area over here. So we need to get our ratio of the areas, set up a proportion. So ratio of the areas, well, like we did here, we're going to square that, is 1/4. So now I can say 1/4, 1 to 4 equals 35 to x. We do cross product and we get 140 centimeters squared. For 54, we are looking at a rhombus, but what's deceiving about this problem is we're looking for the area of this triangle. So it's not the area of the rhombus. Yeah, it's a rhombus, but we're really focused on this triangle here. So it is a 30, 60, 90. I could take half of 12, that's 6. I then multiply that by √3, so I get 6√3. Base and height are 6 and 6√3. So it's 1/2 6 times 6√3. 6 times 6 is 36. Half of that is 18. 18√3 is our answer. It's very easy to get distracted in that problem and then try to find the volume of the entire thing. We don't need, or the area of the entire thing. We don't need that, just the triangle. Read the question. All right. 55. Total surface area of our triangular-based prism. Surface area, our formula is 2 times the base area plus perimeter times height. Let's kind of get the easy parts knocked out first. So, the perimeter, other than that, the height. The height of this prism. Well, these are our bases. The height is the distance between them. It's 15. So that's taken care of. Now we need the perimeter of this triangle. So let's just draw the triangle off to the side. I have 12, 16, and 20. The perimeter of this triangle, our base, is 48. Add them all up. Now I need to find the base area. The base area is 1/2 12 times 16. That's going to be 96, I believe. Let's check that. Yeah, it is in fact 96. That's our base area. I have all my parts. That's 192 plus 720 comes out to be 912. Just to make a note here, if it asked me for lateral area, it would just be the 720. So the answer would be D. Okay, 56. Total surface area for the right square-based pyramid shown here. So surface area of a pyramid, that's going to be base area plus 1/2 perimeter times slant height. Slant height is typically the easiest part to see because that's the distance down the outside of the pyramid, but we don't have that here. We have height, and height is what we would use for volume. So we need to find slant height. I'm going to do that with a right triangle. I'm not going to use 16, I'm going to use half of that, make that an 8. So I have 15, 8, and that is slant height. So L squared equals 15 squared plus 8 squared. We do Pythagorean theorem, and that, in the interest of time, comes out to be 17. So slant height is 17. Now we need our perimeter. So our base is a square. 16, 16, 16, 16. So our perimeter is 16 times 4, or 64. The area of our base is 16 by 16. So that's just 16 squared, which is 256. So 256 plus, let's see, half of 64 is 32. 32 times 17 is 544. We're now adding 256 plus 544, and that gives us 800, which is answer A. 57, surface area of a cylinder. Surface area of a cylinder is based off the formula for a prism, but it's the circular version. So instead of base area, we could say 2 pi r squared. Instead of perimeter, we think of circumference, which is 2 pi r times h. So diameter, they tell us, is 8. Height is 6. Well, if diameter is 8, radius is a 4. So we plug it in. 2 pi times 4 squared plus 2 pi times 4 times 6. 4 squared is 16, times 2 is 32 pi. 4 times 6 is 24, times 2 is 48. Comes out to be 80 pi. 58, surface area for a sphere when diameter is 30. If diameter is 30, radius is 15. Our surface area for a sphere is 4 pi r squared. So that's 4 pi times 15 squared. 4 times 225 pi. 4 times 225 is 900, so we get 900 pi. 59, surface area of a right triangular based prism, and we have base edges of 15, 15, 18, and 30. Our formula is 2 times the base area plus perimeter times height. We know the height's going to be 30 because that's how far apart our two bases are. So we really got that part taken care of. Now we have to find the base area and the perimeter, which can be a little tricky on this problem. So we draw our base off to the side. That's 15, 15, 18. Well, you know, perimeter's not going to be too bad. It's 15 plus 15 plus 18, that's 48. So really all we have left is base area. Now, area of the base, area of a triangle, is 1/2 base times height. Yeah, 18 is our base of this triangle, but 15 is not the height. We need to find that height. And what we're going to do is cut this triangle in half, and it gives us 15, 9, and that's our height. We can use Pythagorean theorem and get 225 equals 81 plus h squared. That turns out to be 144 equals h squared, so height is 12. So our base area, the area of this triangle, is 1/2 18 times 12. That's 9 times 12, or 108. A little tricky there, but we still found the area. So I get 216 plus 1,440, and that comes out to be 1656. Our answer is C. For number 16, we need the lateral surface area of a right cone. Well, before we even find the values we want, let's make sure we get the formula correct. So, if we just think of total surface area for a cone, it's based off a pyramid, which is 1/2, or base area plus 1/2 perimeter times slant height. Since it is a circle, we could say pi r squared for base area, and perimeter is circumference, so that's 2 pi r, but since I have a 1/2, I'm just going to write pi r l. Now, lateral surface area is just this part. So, my lateral area is pi r l. That's all I need to use here. I do not want the base. I want the cone of the ice cream cone. So let's see what we got here. We know the height is 12. We know the circumference is 10 pi. Well, if the circumference is 10 pi, the radius is 2 pi r, so that's just 5. So pi rl, we know radius is 5, we need slant height. So we're going to do Pythagorean theorem. L squared equals 12 squared plus 5 squared. We get 144 plus 25, 169. Our slant height is 13. So now we come down to it's pi times 5 times 13, which is 65 pi. 61, volume of a right regular hexagonal prism, base edge is 14, height is 20. Now our formula for this is base area times height. We know our height is 20. Now we have to find the base area. The base area is the area of a hexagon. Now, I have 14. It's my sides. My area for a hexagon is 1/2 apothem, number of sides, side length. So far, I know I have 6 sides, and the side length is 14. I need to find the apothem. Then I can find my base area. I should probably make that a b. Once I have that, goes into here, I solve my problem. So, we cut that 14 in half. It gives us the 30, 60, 90. That's 7. Our apothem is 7 root 3. Goes here. We simplify this down. It comes out to be 294 root 3. And we get that because half of 14 is 7. 7 times 7 is 49. 49 times 6 is 294 root 3. So we plug that in. We now multiply 294 root 3 times 20. It's 5,880 root 3, and our answer is A. Found the area of that hexagon, then we plug it in the formula. Last page, here we go. 62, volume of a right triangular based prism. So volume is still base area times height. Our height is going to be 20, but we need to find the base area, and it is a triangle. 9 and 15 are not necessarily the values we're going to use because 15 is the hypotenuse. Now, we don't want the hypotenuse. We need to do 1/2 base times height. So, let's just call this b. 15 squared equals 9 squared plus b squared. 225 equals 81 plus b squared. That comes out to be 144 equals b squared. So our base is 12. The area now of this base is 1/2 9 times 12, which comes out to be 56. No, not 56. How about 54? Because half of 12 is 6. 9 times 6, 54. So 54 times 20 gives us 1,080 as our answer. Be careful on this one not to just multiply 9 times 12 times 20, because it's a triangle. It's going to be half of that if it was a prism. So stick to the formulas, find your base area, treat it as a triangle, and you'll get to the right answer. 63, determine the volume for a right cone with slant height 18, radius for the base 9. So volume of a cone, let's start with volume of a pyramid, is 1/3 base area times height. Now, the base area is pi r squared, and that's times height. So, I need the radius, I need the height. 9 is my radius, 18, though, is my slant height. So, I need to find the height. Now, we could use Pythagorean theorem. 18 squared equals 9 squared plus h squared, and it would work just fine. We're going to use a bit of a shortcut, though. If I notice that 18 and 9, that's the indication it's going to be a 30, 60, 90 triangle. So, longer leg is 8, or hypotenuse is 18, shorter leg is 9. That means my height is going to be 9 root 3. If I did Pythagorean theorem, you would get the square root of 243, which is also 9 root 3. So, I'm going to plug it in. 1/3 pi times 9 squared times 9 root 3. we get 1/3 times 81 times 9 root 3 times pi. 81, that. 1/3 of 81 is 27 times 9 root 3 times pi. 27 times 9 is 243, so we get 243 pi root 3 as our answer. So it's C. 64, volume of a right square-based pyramid. That's going to be 1/3 base area times height. So we need to find the area of our base and our height. Let's see, we know slant height's 25. We don't need that for the formula. Pyramid of the height is 24. We do need that one. We need the base area. Now we know it's a square, we just don't know the dimensions of the square yet. So again, we have a right triangle problem here. So it's going to be 25 squared equals 24 squared plus x squared, and that's just going to give us a piece of the, really half the side. If we do Pythagorean theorem, we get x squared is 49, so x is 7. That means our side length is 14. That means the area of the base is 14 squared, or 196. So I need 1/3 times 196 times 24. I could take 1/3 of 24 and just say 196 times 8. And it comes out to be 1,568. That's our answer, which is B. 65, perimeter of the bases for two similar solids are 20 and 32. We need to find the ratio of the volumes. So right now we have perimeter. Now perimeter also works with scale factor because it's just talking about a length, really one dimension. So 20 over 32, we can divide them both by 4. We get 5 over 8. So I want the ratio of the volumes. I'm going to take that scale factor and cube it to go to volumes. So I get 125 over 512. Answer is C. 66, we've given the volumes now. We need to find the ratio of the areas. So volumes are 192 root 5 and 81 root 5. So ratios of the volumes. We can simplify them and say it's just 192 over 81. But I'm going to simplify that even more. I'm going to divide them both by, how about 3? It gives me 64 over 27. Now what I like about this is the ratio of the volumes. I'm going to have to take the cube root to get to scale factor. I can take the cube root of both of these. The cube root of 64 over the cube root of 27, I get 4 over 3. Now, I'm not done yet because I want the ratio of the areas. So the ratio of the areas is going to be 4/3 squared, which is 16 over 9. For our last one, we have the base areas. We can write a ratio of our areas. We have 9 over pi over 25 pi. We reduce 9 over 25. Really, it's simplifying, not reducing. So that's our ratio of areas. We want to find a volume. So let's go from ratio to areas to scale factor. So that means we're taking the square root, which gives us 3 over 5. And now I'm going to ratio of the volumes, which means I'm going to cube it, which becomes 27 over 125. Now, that's the ratio. I'm not looking for a ratio, I'm looking for the volume. So the volume of the larger solid if the volume of the smaller is 36 pi. That's going to let me say 27 over 125 equals 36 pi over x. Because the ratio will hold, so I can use this proportion to help me solve. 125 times 36 pi equals 27 times x. 125 times 36 gives me 4,500 equals 4,500 pi, I should say, times 20 or equals 27x. I get 4,500 pi over 27. This will reduce down. I can divide them both by 27 to 500 pi over 3. I should say I can divide them both by 9. 500 pi over 3. You could also have just plugged in the calculator here and see that it does come out to be about 166.6 or 0.666. Repeating, pi, we see that it's A. So, we made it through all of them, all 67. Hopefully it helps, and hopefully it helps you get ready for that final.